Hi everyone. So today we are going to start with the very first chapter of meteorology, that is the atmosphere. But before that, we need to understand what is meteorology. But basically, meteorology is the science or the branch of science which helps us in dealing with the Earth's atmosphere and all the physical processes which are occurring in the atmosphere. Now, why do we need to study meteorology? That is basically to understand the physical processes or the changes that are occurring in the atmosphere, or to understand the meteorological hazards which may be caused to the aircraft while in flight, and how we can reduce the risk of those hazards on the aircraft. And we need to identify the weather before each flight, the en route weather, the destination and the departure weather, to interpret the actual and forecast weather conditions. Then is we can analyze the and evaluate the weather before the flight and also in flight. And we also can find or devise the solutions to the problems presented by weather. Whatever the problems are created due to the weather conditions, we can find the condition we can find some solutions to those. Then is definition of atmosphere. Atmosphere is a gaseous envelope surrounding a heavenly body, or we can say atmosphere is the gaseous envelope surrounding our earth. The constituents of the atmosphere by volume we are talking: nitrogen 78%, oxygen 21%, argon 0.93%, then is carbon dioxide 0.03%. Plus, there are some small traces of gases such as neon, krypton, hydrogen, nitrogen oxide, carbon monoxide, ammonia, helium, nitrogen dioxide, sulfur dioxide, methane. Also present are some solid particles. And in particular, we need to learn about water vapor also. From the meteorological point of view, we can say that water vapor is the most important gas in the atmosphere. Now, the proportion of the constituent, it remains up to a height of at least 60 kilometers, except for ozone. So, at lower levels, mixing processes occur in the atmosphere, but as we move at a higher level, the mixing processes they no longer exist. Although the small traces of ozone in the atmosphere is important, as ozone helps us shield the atmosphere against ultraviolet radiations which are harmful, which may even cause sunburns or the skin cancer, we can say. So ozone is somehow important also, but it causes some hazards to us also. Now, what are the properties of Earth's atmosphere? Earth's atmosphere, it varies, actually varies horizontally as well as vertically. Vertically and horizontally in terms of pressure, temperature, density, and humidity. So, the Earth's atmosphere varies vertically and horizontally. Pressure से करेगा, also with the temperature, the density, and the humidity. Earth's atmosphere, it is a fluid and it supports life only at lower levels, and it is a poor conductor of heat and electricity. Then we'll talk about the structure of atmosphere. The very first layer is the troposphere. It is the lowest layer of the Earth's atmosphere, where the temperature will decrease with increase in height. As this means, as we move to the higher levels, the temperature will decrease, and this is in the normal layer only. It consists of three-fourth of the atmospheric mass, three-fourth of the total atmosphere's mass, that is 75%, and almost all weather activities they are confined to the troposphere. We also need to know that all the weather activities will be confined to only those layers where those are unstable. In the stable layers, you will find that there are no weather activities. So this means that troposphere is an unstable layer. Then we talk about tropopause. Tropopause is basically the boundary between troposphere and the stratosphere, and temperature ceases to fall with height. That means the temperature will now either be constant or it can increase with height but will not fall. The height of tropopause is controlled by temperature of air near the surface. Whatever would be the temperature, that would be the defining factor for the height of the tropopause. The warmer the air, the higher the tropopause. Wherever the air is warmer or the temperature is so high, there only the height of the troposphere will also be more. This means during winters we'll observe that the height of the tropopause is lower than that in case of summers. Now the temperature, it can vary due to the latitude, the land and the sea, due to seasons, and it will also cause changes to the height of the tropopause. As we know that the tropopause, it will be at a higher altitude in case of warmer region. So there are two locations where this tropopause, it will abruptly change the height or folds. We call it breaks or folds, and these are approximately at 40-degree latitude and 60-degree latitude. But we need to know that among these two latitudes, 40-degree and 60-degree, the breaks or the folds or the abrupt changes of height of tropopause, it is more prominent at 40-degree latitude. Now we'll talk about the average height of tropopause at the equator at 16 to 18 kilometers, and average temperature here is minus 75 to minus 80 degrees Celsius. Or according to IC Joshi, we consider this average temperature to be minus 70 to minus 75 degrees Celsius. And at the poles, according to IC Joshi, if we go, it is 8 to 10 kilometers with average temperature of minus 40 to minus 45 degrees Celsius according to IC. The average value at 50 degree north, it is 11 kilometers, 36090 feet. Temperature is minus 56.5 degrees Celsius. Temperature of tropopause is controlled by height. Higher it is, the colder the temperature. The lower it is, the warmer the temperature. The temperature at the tropopause, it can be as high as minus 40 degrees Celsius over the poles and can be as low as minus 80 degrees Celsius over the equator. So this diagram represents the folds or the breaks that we've learned just now. Then is the significance of tropopause height, because it is the maximum height where the clouds can reach. Here is the presence of jet streams, clear air turbulence, which we call cat, and now we also call it as turb, turb, turb. The maximum wind speed and the upper limit of most of the weather, because I told you that weather is mostly confined to the areas which are unstable. So this means if tropopause is the upper limit of most of the weather activities, this means that all the layers over the tropopause, they are mostly stable. Now we come on to stratosphere. Stratosphere, it is the layer above troposphere where temperature here initially remains constant to an average height of 20 kilometers, and then it will increase to reach the temperature of minus 2 degrees 2.5 degrees Celsius to height of 47 kilometers. And we also need to learn that above 51 kilometer the temperature will start decreasing again. Now we come on to temperatures. Temperature in the troposphere increases from poles to equator. From the poles, as we move from the poles towards the equator, the temperature starts rising. Temperature in lower stratosphere increases from equator to poles, but reaches maximum temperature is in mid latitudes in winter. Then is international standard atmosphere. Because temperature and pressure, they vary with time and position, both laterally or horizontally and also vertically. It is therefore necessary in aviation field to have some standard conditions, the set of some standard conditions, or we can say a common datum for all, which would also help us in the calibration of the aircraft pressure instruments. There are two types of instruments we know: pressure instruments and gyro instruments. So, for the calibration of the pressure instruments, such as the altimeter, we need to set a standard atmosphere internationally. That is the ICAO ISA, International Standard Atmosphere. It says that the temperature at the mean sea level is plus 15 degrees Celsius. The pressure is 1013.25 hectopascals. The density is 1225 grams per meter cube. The lapse rate of temperature is 0.65 degrees Celsius per 100 meter or 2 degrees Celsius per 1000 feet up to 11 kilometers. Or we can also say 6.5 degrees Celsius per kilometer. A constant temperature of minus 56.5 degree from 11 kilometers to 20 kilometers, and therefore the temperature increase rate is zero point 0.1 degree Celsius per 100 meter or zero point 0.3 degree Celsius per 1000 feet up to 32 kilometers. ISA deviation. If we want to calculate the ISA deviation, it is basically the difference between the actual condition and the ISA condition. So for calculating the ISA temperature, we know the lapse rate is 2 degrees Celsius per 1000 feet and 15 is the mean sea level temperature. So 15 minus 2 times the altitude in 1000 feet, or we can say 15 minus 2 into altitude by 1000. We also need to remember that from 36,090 feet to around approximately 65,000 feet, the temperature is almost constant and is considered either we can say minus 56.5 degrees Celsius or it can be minus 57 degrees Celsius. So here is the formula for ISA deviation. It is actual temperature minus ISA temperature. So here we're done with the first chapter. Thank you.